Okay, section 3.3, differentiation rules. In this section, we're going to talk about different kind of rules for finding the derivative. First rule is, if your function is constant, then rate of change of that function would be 0. There would be no change. For example, let's say the function is f of x is 5. 5. Just for example, it's a constant function. If you look at the graph of this function, you can see that function is 5. So there is nothing is changing. So derivative means rate of change, changing rate. And if we are dealing with a constant function, then there will be no change, meaning the change would be 0. That's why the derivative of constant function is 0. So these are the different notation, du over dx or f prime. Both of them represents the same thing. It's a derivative. So after this point, now whenever you see a constant function, the derivative of that constant function is 0. So this is called power rule. If you see x to the power, for example, 5, if you want to find out the derivative of that x to the power 5, remember this is the notation for derivative. It means whenever you read it, you say derivative of x to the power 5 with respect to x. Rate of change of x to the power 5 function with respect to variable x. And they come always together, d over dx. D and dx, they are not separate, they come together. This is just one single notation. It means derivative of function right after this. So by using this formula, the derivative of x to the power 5 would be 5 times x to the power 5 minus 1, which is 4. So the rate of change of this function x to the power 5 by using this formula would be 5 times x to the power. So in this case, it says n is positive integer, but that's not required. N could be any real number. Still, we can use this formula. This is called power rule, the derivative. Okay? So x to the power n, keep in mind, you see x to the power n, want to find out the derivative of that kind of function. This n goes front, you have to reduce this n by 1, which is that is the. So if there is a constant times some function, you can always bring that constant side and find the derivative function one. For example, let's say there is a 5 times x power 3. Find out the derivative of this. You can bring this 5 outside. Just multiply derivative of x cubed by 5. By using the power rule, derivative of x cubed is 3 times x, 3 minus 2. 3 minus 1 is 2. By using the power rule. So eventually it's 15 times x. If we have to find out the derivative of sum of the function, that would be actually sum of the derivative of those respective function. We can just distribute this derivative if there is a plus or minus sign. That's called sum rule. For the exponential function, rate of change of exponential the function itself. Now, this is very important rule that's called product rule. You see the product of the function. Let's say there is a function f of x and there is a function g of x. If you want to find out the derivative of this product, then the derivative would be find the derivative of the first function, leave the second function, plus leave the first function and find the derivative of the second function. The derivative of the product is not product of the derivative. It's this rule. This is called product rule. So you always have to keep in mind if there is a product, it should be the same case. If you have more than two functions, you might have 100 different function product of the 100 different function. If you are trying to find the derivative of those product, then you have to find the derivative of the first function times the leftover function plus you have to leave the first one now times derivative of the leftover function. This is called product rule. There is a quotient rule as well. If there is a division, for example, let's say function on the top is u, the function on the bottom is v. If you want to find out the derivative, then the formula is on the top you have to put v, which is the function from the denominator, times the derivative of the function on the top minus function on the numerator times the derivative function from the bottom divided by the square of the function on the bottom. But make sure that this rule only works if the bottom function is not zero. This is called quotient rule, division rule. So now we're going to use these rules: division rules, product rule, sum rule, power rule, to solve a couple of examples. First example is find first and second derivative. The first derivative, the derivative of this function with respect to time. Remember, the variable in this case is time, t. That's why we find derivative of s with respect to t. Now, we can use more than one rule together here. So when we try to find out the derivative of this kind of thing, there is a sum rule, so we can separate them this as derivative of the first function excuse me, minus derivative of the second function. This is possible because of the sum rule or difference rule. That's the same thing. Now we can bring this 7 outside and we can find out the derivative of t to the power 4. We can bring this 4 outside and find the derivative of t to the power 7. And now for that one we can use the power rule. It is 4 times t to the power 3. 3 means 4 minus 1. That's the formula. 4 times 7 times t to the power 6. 7 times 4 is 28. T cube minus 4 times 7 is 28. T is 6. So that's your first derivative of this function. You want to find out the second derivative? You have to do the same thing for this function now. This is the new function, which is derivative of the first function. So how do you use this notation for the second derivative? You can say, okay, this is my, you can name this as a different name like h of t, and then you can find out the derivative of that new function. Or you can write down this way, d2 over dt square. This is the notation for the second derivative with respect to time of the function s, which is actually the first derivative of this one, which is 28 t cube minus 28 t6. By using the very similar approach like the thing we did here, find the derivative of this thing, you need to find the derivative of them separately. It would be 28 times the derivative of t cube, which is 3 times t square, minus 28 times derivative of t6, which is 6 times t to the power 5. So eventually it's 28 times 3 is 84. T square minus 28 times 6 is it's a 168 t to the power 5. So that is the second derivative of the original function, but this is the first derivative of this function. Find y prime by applying the product rule. So first we apply the product rule. If you remember, the product rule is derivative of the function f of x times g of x. Product is the derivative of the first function times the second one plus first function times the derivative of the second one. Okay, so in this case, let's say this is f. See, to apply this product rule, find out f prime. F prime means derivative of this function, which would be derivative of 3, which is 0, minus derivative of x square, which is 2x. That's f prime. G prime is derivative of this part. So the derivative of the first is 3x square minus the derivative of second one is negative 4, and the last one, the derivative of 4 is 0. So f prime is negative 2x, g prime is 3x square minus 4. Now if you want to find out the y prime, means you have to use the product rule, so you have to just copy this thing, f prime times z plus f times z prime. So plug the value of f prime, which is negative 2x, g of x, which is x cubed minus 4x plus 4 plus f is 3 minus x square times g prime, which is 3x square minus 4. Now, now you can simplify this one. So now first is apply the product rule. So we apply the product rule. This is the product rule. Now part B is multiplying the factors to produce a sum of simpler term to differentiate. So you just multiply the factors so that you can simplify it. That's a part B. So this is part A. Part B is just multiply them. If I multiply this, if I just distribute this negative 2x here, it will give me negative 2x to the power 4 positive 8 x squared negative 8x. Here in this case it will be 3 times 3 is 9x squared minus 12 negative 3x to the power 4 positive 4 times x squared 4x squared. So this is the product. We can just simplify. You can see that there is a x to the power 4, there is x to the power 4. We can combine that. That will give us negative 5x to the power 4. And after that there is x square x square x square. So 8 plus 9 plus 4 is what is that? 9 plus 8 is 17 plus 4 is 21 x squared. So this is gone, this is gone, 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 this is gone. So negative 8x, finally negative 12. So gone, this is gone. So everything gone. So this is the simplified version of the derivative. Okay. Find the derivative of the function. As you can see that there is a quotient, so we have to remember the quotient rule. See, it's the quotient rule is leave function from the denominator, find the derivative on the top, minus leave the function on the numerator, find the derivative function from the bottom, divided by square of the square of the function on the bottom. So in this case, this is f, this is d. Find out f prime, which is derivative of 5x plus 7. Derivative of 5x is 5, 7 is 0. D prime is derivative of 2x is 2, and derivative of 5 is 0. So now we're going to use this formula for finding the derivative of this y. This is the notation. Derivative of y with respect to x is, y means f over z. Okay, just copy the value for this one. G means it's 3x minus 5 times f prime, which is 5, minus f, which is 5x plus 7, times g prime, which is 2, over g square, which is 2x minus 5. Now simplify if it's possible on the top. 2x times 5 is 10x minus 25 minus 10x. Negative times negative is negative times positive is negative 14 over 2x minus 5 square. So on the top, this negative 10x and this positive 10 cancel out. Negative 25 negative 14 is negative 39 over 2x minus 5 whole square. That's the derivative of this y. This is the final answer. Okay. Find all the points xy on the graph of the function with tangent lines parallel to the line this. So two lines are parallel. Any two lines are parallel if their slope are same. So let's say the slope of the first line is m1, slope of the second line m2, and if they are same, that means those lines are parallel. So in this case, we want to find out the value of xy such that the tangent line on this curve is parallel to this line. So what we can do is we can take the slope of this line, slope say m2, it's 7. So we want to find out the slope, we want to find out the point xy on this curve such that the slope is 7. So first of all, find out the slope. Slope means derivative. Slope, say m1, is actually the derivative of this function, which is if you use all the rules, first the power rule should be 3 times 2 times x minus 5 times x to the power 0, which is just 5. So this is 6x minus 5. This slope and this slope, this would be equal to be parallel. So 6x minus 5 should be equal to 7. We try to solve for x. It gives us x equal 2. So when x is 2, we can find out the value of y by plugging x equal to 2 here. So when x is 2, the value of this function here would be 3 times 2 square minus 5 times 2, which is 12 minus 10, which is 2. So when x is 2, the y would be 2. At this point, the slope, the tangent line, if you draw the tangent line on this curve at this point, the slope of that tangent line would be 7, which is same as the slope of this line. So that means they will be parallel. So this is the point where uh, the tangent line would be parallel to this line.